I'm talking about developing a rapid method for determining grapevine nitrogen status. So this is important to manage the nitrogen in the vineyard, not over the whole season, not just a time point. So a bit of background on this. Optimizing nitrogen supply in the vineyard is really critical for fruit and vine production. But it's important to balance the nitrogen availability for canopy growth and also for productive development. So this means including fruit maturity and grape composition at harvest, particularly if you think about yeast distilled nitrogen, important for the fermentation. So if you frequent monitor the nutrient status, that helps to predict what's happening and also can better target the inputs. So one way of doing it is measuring is indirectly. A spectrometer is one of the options there to monitor this nitrogen status to dynamic changes during the season. And that will help to identify the nitrogen requirements all the way through until leaf fall, really, because there are a number of changes that are happening. If you break up the dynamics or the seasonal changes over the 4 major parts of the season. So at bud break, a lot of the nitrogen is coming from reserves, so from the mineral structure. So it's quite important to have these levels right at the start of the season because the soil is still cool. And then at bloom, flowering, the reserves still play an important role, but now the uptake takes place, and this is continuing in that period until the horizon. The reserves play less of a role, but now we have the ripening period, so there's still a lot of uptake there, depending on the yield. Some of it flows back into the reserves. But more importantly, after harvest, that's when if the reserves, nitrogen reserves are depleted by a large crop or a drought situation, then it becomes important that the reserves are filled up for the next season. Of course, that if there's a post-harvest period in some cooler grape-growing regions, that's not the case. So these reserves have to be filled out pre-leaf fall or pre-harvest. So there's some key points during the growing season where nitrogen, for instance, plays a particular role. So for vegetative growth, this is the shoot growth, but also later in the season, at the end of the season, if they're well supplied with nitrogen, leaf stay on longer. In addition, nitrogen plays a role in the reproductive development, in initiation of inflorescences, and then in the following season, on berry growth, it's important to berry growth, and of course, later on also nitrogen is important for not so much for ripening itself, but for the composition of the berries and the must. So when we look at the dynamics and at some of the background information for understanding nutrient dynamics, so the concentrations in the perennial structure has only minor changes. So here everything which is in black, but the concentration changes in the annual parts, and most relevant here would be the leaves for indirect measurements. They steadily decline. So they go up from 3% and eventually sort of end up with 1% concentration. So there's quite a change there. And it's even more substantial when you look at the total amounts, what is in the grapevine. At the start of season, it might be, in this case, the Shiraz vines, 35 grams or close to 40, and then that the peak is reached at harvest because there is a lot of nitrogen in the annual, in the new growth and the crop. A lot of that not comes from uptake, as indicated earlier, it comes from the perennial structure. So that uses the nitrogen is shifted to the annual growth. Now, of course, here at harvest, we have this removal of nitrogen and some of remobilization from the leaves into the stems and perennial structure, and further uptake indicated here. So you basically end up with a slightly higher amount in a total basis for the vine at the end of the season. So there are quantitative assessments. So commonly in Australia, we use tissue analysis and PTL levels at flowering, and we have certain ranges to where they should sit for optimal production levels. So that relates, the ranges relate to yield. But then we can also do tissue analysis at horizon, PTL levels at horizon. That relates more to composition, as you can see here when you plot PTL nitrogen against yeast similar nitrogen levels. So the must, what the yeast can access for their growth during fermentation in the must, and it's particular more close. It's closely related if you look at horizon values. One of the earliest things we did is used FTIR, and that speeds the process up. There were good relations between measured nutrients and what the spectra gave us. So, but you still need a powder, as you can see. You put a powder underneath there, and it gives you a spectra which relates to not only nutrients, also to carbohydrates. So the important thing is here, I mean, it works for most macronutrients very well. So we have the measured values here, and again, this is and then we have got the predicted values here. So, and this is the ranges where we want to, between 0.8 and 1.1 here, where we want the PTL's levels sitting. So but there are a number of indirect measurements. We have got the methods to do it with tissue analysis, using a nitrogen analyzer, for instance. But there's a number of indirect measurements, optical meters, which we can use to assess nitrogen levels. And here's one of what we call a chlorophyll meter. That's one of those things to assess or to give a good indication of nitrogen levels in the plant. It's a very good instrument to measure this indirectly. Of course, you can be close to the leaf at leaf level, but you also can be away at ground level. So you can even go to satellite, but that gets less accurate. But the advantage of this is that we understand the variation within an orchard or a vineyard. So we have this done on PTLs, and there's a very good correlation between PTL and laminar levels, as you can see here, both times, horizon and flowering. So we can adopt them to indirect measurements. But again, there's, as I outlined, there's an issue with the concentrations of nitrogen during the season, going from 3% to really low at the end of the season. So that has to be taken into account if you do more frequent measurements. So it needs a bit of time to develop standards throughout the season. What's optimal. So for that, we did this experiment in winter, strangely enough. So it was just done under controlled conditions on Shiraz wines. So we had to put them to sleep and then bake them up again to give them some chilling in a cool room for a few weeks. And then we implemented a number of treatments, which we sort of judged to be what they need during the growing season, the size of vines they were. There was also treatment where they received no nutrients at all. So it was done in the glass house, as I mentioned. So we used a spectrometer for this. So we measured a whole range of wavelengths, but we did this over 3 times. And we also did that at 3 spots on one leaf, and the leaf opposite the basal bunch, that's the most critical one in some respect, because that's where we do all our standards from. So that's a standard procedure where we take PTO levels, but then again 4 and 6 leaves above that position. And yeah, we get quite a difference there in 550, and that's what I'm focusing on here. So as you can see, we have this 4 treatments and 3 leaf positions at 3 times. So months before flowering, and a month after flowering, and we get a range between the treatments and also in some respect to leaf position, where the leaf is positioned. Most commonly, well, particularly when they're deficient, we have lower levels at the lower leaves, which is no surprise because it's mobilized. And then, of course, in time, we're going to get decline as well. So I guess we got really a big range of nutrient levels from 4.5, nearly 4.5 there to 1.75. That was the aim, to have a lot of a large range there. So when we looked at opposite the basal bunch, so that's the important one, the position 1. So we get a good relationship between, or through this, through all these different concentrations. So a good way of predicting indirectly. And if you look at the 4 leaves, position 2 and position 3, position 2 was also good, but then P3 was a bit variable, particular, that will come out in the next slide. At the first timing, there was a lot of variation there, how the in the measurement. So that was mostly due to that position 1. Then the other times at flowering and after flowering, we got, again, very good relationships between reflectance and the actual measurements with a nitrogen analyzer. So in conclusion, so the first thing is that for nitrogen, it's not true for all nutrients. They're very closely related. There's a close relation between leaf and PTO levels. So very good for calibrating and for indirect measurements, in this case with the spectrometer. So the leaf concentration were altered. We created quite a range of nutrient levels, of nitrogen levels. in time, position of leaves, and also the treatments. But these changes were more pronounced in the lower leaves and later in the season. And the reflectance using immunospectrometer showed strong relationships with nitrogen leaf concentration regarding to position on the stage. There's an issue there. So to make judgment what's correct at a certain time, we need to first understand what's happening during the season. But this will really help if we make this accurate prediction to more precise with the applications of nitrogen. With that, I thank you for your attention and acknowledge that the work was supported by our center and also by some of our technical staff. Thank you.